Hi students, this video is going to help teach you how to write an equation for an exponential function. So first of all, this is the equation that we're looking at. This value is what we call our initial value. We can also call that the y-intercept. And then we have our b, and the b is our multiplier. The x and the y are both going to just be part of your function. The a and the b are what we're going to determine, and then we'll be able to write the equation. So there's three things I'm going to show you. One is starting with a table, the other is starting just with information, and the third is from a graph. So if we look at this table here for number one, we could look at this and say, let's see, could this be linear? So we're adding 1 each time here. From 1.5 to 3, I would add 1.5, or 1.5, same thing, we can just write that to be consistent. If I add 1.5 again, I don't get to be at 6. So right away I know this does not have a constant rate of change. It is not linear. So we want to see, is there a common multiplier? So to get from 1.5 to 3, we would double it. Does this work for all of them? To get from 3 to 6, we would double it, and 6 to 12, we would also multiply by 2. So we have the common multiplier, which is 2. Now we want to see what is our initial value. So initial value is our y-intercept. So we see this point right here, 0, 3. Think of this on a graph. 0, 3 is right here. That's your y-intercept. So if we have a 0 as the x-coordinate, that is going to be always your y-intercept. So that is my initial value. And often we'll put that 2, or the base in this case, in parentheses. Okay, so that is your model. Now another type of question you're going to see is I'm going to actually tell you, hey, here's the initial value, and here's the common multiplier. So this one, if I'm telling you already it's exponential, you can just put the initial value in, the multiplier, and raise it to the x power. Okay, the third one here I'm going to show you is if you're given a graph. Now you have a couple of options here. You can take a look at, we were going from 36 to 12. So that is multiplying by a third, and then this is actually at 4. So we would be going by a third again. Notice this is an exponential decay because as I move to the right, my outputs are getting smaller and smaller and smaller. Sometimes it's a little hard to see in the graph. So what you could also do is just make a quick table and put in the points you know. So I know -1, 36. I know 0, 12, and I know 1, 4. And then I could say, what do I multiply 36 by to get 12? Looking the other way, you can probably see you multiply by 3, but we're decreasing here, so it's going to be times 1/3. If you think divided by 3, that's the same as times 1/3. So the multiplier, we do need it to be multiplication, but there's different ways that you can think about it. And these are going up by 1. So we can write our equation here. Again, we see that initial value is right here on the y-axis. And we see it again if we write it in the table. The multiplier is a third, and it's raised to the x power. And that's your equation for your exponential.